This video demonstrates the setup of the linearization curve for a basic milk-water interface application. In this case, we've pre-prepared some samples, placed them in opaque cups with 0% milk through to 100% milk, being in a milk-water solutions. In this case, we're using an MXD73 and an S20 sensor. You can see here the probe signal value. This is the raw data value that we're going to relate to. First, we move to channels. Then we select the channel that the sensor is that we're setting up. Make sure it's enabled. Move down to units. Insert the value of the units that we want, in this case percentage. Then choose the range. In our case, we're choosing 999.9. And then we then move to the setup curve itself. We've chosen 5 points. That's a good number. 3 is okay, 5's better, and 10's quite extreme. You'll get outstanding results from that. Then move to the first point. Input the percentage value, being 0% in this case, just straight water. Place the sensor, ensuring that the sensor is as centered as possible to get the reflectivity as equal as possible. Then push enter. You'll see that the probe signal value is being detected. It's sampling, and then once that is complete, it will then apply a probe signal value to the actual percentage. Remove the sensor from the solution. Give a quick wash, a dry, so as to ensure there's no cross-contamination. Make sure the sample's well stirred. Place the sensor in the sample, and then go through those steps again. So move to the second point this time. Press auto. Input the value of the percentage, in this case 25%, and then press enter. Again, the sensor does the sampling and relates the probe signal value to the percentage value that you've just input. Repeat the same process, cleaning and drying the sensor to ensure there's no cross-contamination. Again, making sure that you stir the samples. It's also very good to ensure that the samples are of a balanced temperature. Move on to step 3. Same process again. Inputting the percentage value and pressing enter. And just step through the rest of the samples doing exactly the same thing. Remembering that we're using plastic opaque cups here with minimum reflectivity. It will be different than the actual pipe, so you may need to do some testing just to cross-check that later. Once you've completed the testing, cross-check your results and make sure that they're pretty close. If they're not too close, this could be a result of maybe the sensor not being quite central, maybe the temperature changing a reasonable amount, or possibly your samples are not quite as accurate as you'd expected them to be. That'll also give you a slightly different outcome. Remembering all the time that the algorithm we use is incredibly repeatable. So it's not in the sensor, it's in the variables around the setup of the sensor, if you get any difference. In this case, we're pretty good, and that everything's very, very close as it should be.